Hi, so for in this video, I will explain about key switch and how its program works. Okay, so first thing first, I will show how my key switch works. Okay, so for example, when I press the key 1, the LED, which is RB4, will turn on, and then when I press key 2, the LED RB5 will turn on, and then when I press the button key 3, the LED RB6 will turn on, and then when I press the key 4 button, the LED, which is RB7, will turn on. Okay, so let's move to the program and see how the program works. So first thing first, all the coding here, it shows that how the initialization of port C and port D configuration, and then for this, it sets all pins on port C as outputs, and then for this thing, it means that it will initialize all pins on port C to logic high, and then for this switch D, 0 times 0 0, it will set port D. It will set all pins on port D as outputs, and then for this, it will initialize all pins on port D to logic high. Okay, so for port B configuration, for this one, it will set the lower nibble, which is RB0 to RB3 of port B as inputs, which is 4 buttons. For example, here we have RB0 and until RB3. So from RB0 until RB3 of port B, it functions as inputs for buttons, and then the upper nibble, which is RB4 until RB7 as outputs, which is like this. So RB4 until RB7, it functions as outputs. And then the next one, we have port B equal to 0 times 0F. So this enables the pull out resistors on the lower nibble, and then for this one, it enables weak pull up resistors on port B. Okay, next we have this as main loop, which okay, so first thing first, for read button state, for this, key equal to port B and 0 times 0F, it reads the lower nibble of port B, isolating the states of the buttons, which is RB7 to RB3, and then if no button is pressed, key will be 0 times 0F, which is all bits in the lower nibble are high due to pull-ups. And then for check for button press, this if key equal to 0 times 0F, it will check if any button is pressed. For example, at least one bit in the lower nibble is low. And then for this, for delay, which is delay MS20, this delay is introduced to debounce the button press. And then for this, key equal to port B and 0 times 0F, and if key equal to 0 times 0F, it for reread button states. So after debouncing, this will recheck the lower nibble, and if a button is still pressed, which is for this, it proceeds to identify which button was pressed and identify and respond to, and therefore identify and respond to button press. For this, a switch key statement, for this, a switch key, which is a switch key. This statement determines which button was pressed based on the value of key. For example, for this, when the button key 1 is pressed, which is RB0 press, it will turning on the LED corresponding to bit 3 active low. And then when the K2 press, which is RB1 press, it will turning on the LED corresponding to bit 2, which is active low. And then for this, when key 3 button is pressed, it will turning on the LED corresponding to bit 1, which is active low. And then for this, when key 4 button is pressed, which is arbitrary press, it will turning on the LED corresponding to bit 0, which is active low.